Imagine looking up at the night sky. The darkness above is sprinkled with countless points of light, each one a distant sun shining across unimaginable distances. For thousands of years, humans have gazed upward, wondering what lies beyond those twinkling stars, searching for meaning and our place in the cosmos. Each star is a sun, possibly with its own planets, some of which might even harbor life. The universe is teeming with possibilities, and every star is a beacon of curiosity, inviting us to explore further. But if we zoom out beyond the Milky Way, we see the universe isn't random. It's woven into a vast cosmic web. This web is a structure so immense that it stretches across the observable universe, connecting galaxies and clusters in a delicate, intricate pattern. This web is made of empty voids and long filaments, connecting at dense clusters of galaxies. These filaments act like cosmic highways, channeling matter and energy across the universe, while the voids are vast, nearly empty expanses. Earth is a tiny speck in this grand tapestry, part of the largest structures in existence. Our planet orbits an ordinary star, in an ordinary galaxy, yet we are part of something truly extraordinary. Our galaxy, the Milky Way, belongs to a group, which is part of an even larger supercluster. These superclusters are the building blocks of the cosmic web, stretching for hundreds of millions of light years. For years, we thought we had mapped our cosmic neighborhood, tracing filaments and clusters. Astronomers have spent decades piecing together the structure of the universe, using powerful telescopes and innovative techniques. But the universe always has surprises, hidden structures that challenge our understanding. Just when we think we have it all figured out, new discoveries force us to rethink what we know. These structures span hundreds of millions, even billions, of light years, containing thousands of galaxies. The scale is almost beyond comprehension, dwarfing anything we can imagine on Earth. It's a scale that can make us feel small, but also deeply connected to the cosmos. We are part of this grand design, woven into the very fabric of the universe. Our quest to map this web is driven by curiosity, a need to know our place in the universe. Every observation, every discovery, brings us closer to understanding where we fit in the cosmic puzzle. Every discovery adds a piece to the puzzle, refining our understanding of cosmic evolution. The more we learn, the more we realize how much there is left to uncover. From subatomic particles to the largest walls, it's all part of the same cosmic story. The universe is a tapestry of connections, from the tiniest building blocks to the grandest structures. And recently, we uncovered a structure so massive and so close, it had been hiding in plain sight. This discovery reminds us that the universe still holds many secrets, waiting to be revealed. This is the story of the South Pole Wall, a colossal structure that challenges our understanding of the universe and our place within it. The South Pole Wall, a colossal filament of galaxies, stretches an astonishing 1.4 billion light-years across the cosmos, making it one of the largest known structures in the universe. Imagine a structure so vast, it defies our everyday sense of scale, spanning a distance that light itself would take over a billion years to cross. Picture a string of pearls, but each pearl is not a simple bead, but an entire galaxy, each containing billions of stars, planets, and mysteries. The string itself is unimaginably long, weaving through the darkness of space, connecting these cosmic jewels in a breathtaking formation. This wall is a concentration of gas, dark matter, and galaxies, forming a cosmic boundary. It's one of the universe's largest and most impressive structures, a testament to the grand scale and complexity of the cosmos. Located near the celestial South Pole, the South Pole Wall sits just beyond our own supercluster, Laniakea. It's a hidden neighbor, only recently revealed by astronomers mapping the universe in 3 dimensions. If the Milky Way is our house and Laniakea our city, then the South Pole Wall is like a vast, towering mountain range just outside the city limits, an immense frontier waiting to be explored. Its scale is staggering. 14,000 Milky Ways could fit end to end along its length, a number almost impossible to truly comprehend. It's a reminder of how small our own galaxy is in the grand tapestry of the universe. The wall contains hundreds of thousands of galaxies, all bound together by the invisible force of gravity, forming a dense, curving curtain that stretches across the southern sky. It's not a solid wall, but a region where galaxies are far more densely packed than elsewhere, creating a cosmic landscape rich with clusters, filaments, and voids. The South Pole Wall is a major filament in our local universe, connecting clusters and superclusters and helping to shape the large-scale structure of the cosmos. Its discovery was monumental, not just for its sheer size, but for how close it was to us, hidden in plain sight until now. The South Pole Wall reminds us that even in our cosmic backyard, there are still wonders waiting to be found, challenging our understanding of the universe and inspiring us to keep exploring. The South Pole Wall was discovered in 2020 by astronomers Daniel Pomered and R. Brent Tully. Their work marked a turning point in our understanding of the universe's vast structure, revealing something truly extraordinary lurking in the cosmic shadows. Unlike traditional discoveries made by peering through powerful telescopes, this breakthrough came from building a detailed 3D map of the universe. The astronomers meticulously pieced together data, layer by layer, to reveal what lay hidden beyond our direct line of sight. The South Pole Wall was concealed behind the dense plain of the Milky Way, in a mysterious region known as the Zone of Obscuration. This area is so packed with stars, gas, and cosmic dust that it blocks our view of anything beyond. Imagine trying to spot a distant mountain through a thick, tangled forest. The stars and dust of our own galaxy acted like a curtain, making it nearly impossible to see what was on the other side. To overcome this cosmic obstacle, the team turned to data from multiple astronomical surveys, combining measurements of galaxy positions, distances, and their subtle motions through space. By carefully tracking how galaxies moved relative to one another, they could infer the presence of a massive, unseen structure, exerting a powerful gravitational pull. In the southern sky, galaxies weren't just drifting randomly, they were being drawn together, as if pulled by an invisible hand. This pointed to the existence of a huge gravitational attractor. It was like mapping the flow of ocean currents to discover hidden continents beneath the waves, using the movement of galaxies to reveal what the eye cannot see. The team mapped these cosmic flows in detail. They found that galaxies weren't just expanding outward with the universe, but had an extra motion, an unmistakable drift toward the South Pole Wall. This peculiar velocity, this extra movement, was the signature of something enormous, a structure so massive it could tug on entire galaxies. By tracing these subtle but significant movements, the astronomers finally unveiled the South Pole Wall, a colossal feature hidden for eons by the brilliance of our own galaxy. A giant, right on our cosmic doorstep, reminding us how much of the universe still waits to be discovered, just beyond the dust and stars. The South Pole Wall's discovery shocked astronomers, mainly because of its proximity, just 500 million light-years away. It's like finding a new continent next door. Such a massive structure, so close, had gone unnoticed for so long. This challenges our leading cosmological model, Lambda CDM, which predicts how structures form over time. According to the model, gravity assembles small clumps first, then larger ones over billions of years. The South Pole Wall's size and mass push the limits of what should be possible in the universe's age. It suggests either structures can form faster than we thought, or the early universe was lumpier than assumed. The wall's gravity also affects our galaxy's motion, adding a new player to the cosmic tug-of-war. For years, astronomers tried to explain our galaxy's movement. Now, the South Pole Wall helps complete the picture. It's a crucial piece in understanding our cosmic neighborhood, and it forces us to rethink what we know about the universe's evolution. The South Pole Wall isn't alone. Other cosmic giants exist. The CFA2 Great Wall, discovered in 1989, was the first, stretching 750 million light-years. Then came the Sloan Great Wall, 1.37 billion light-years long, once the largest known structure. The South Pole Wall rivals the Sloan Great Wall, both at the upper limits of what gravity can assemble. Our home supercluster, Laniakea, is different. A region of 100,000 galaxies flowing toward a central point. Laniakea sits next to the South Pole Wall, which tugs on its galaxies with immense gravity. Other contenders, like the Hercules Corona Borealis Great Wall, are debated, but the South Pole Wall's existence is certain. It stands as one of the most massive, well-mapped structures ever discovered. How do you find a structure hundreds of millions of light-years away? Astronomers create 3D maps of the universe, one galaxy at a time. First, they identify galaxies using powerful telescopes and sky surveys. This gives a 2D map, but to see walls, they need depth, distance. They measure distance using redshift, The farther a galaxy, the more its light is stretched. By plotting thousands of galaxies in 3D, the cosmic web emerges: filaments, clusters, and voids. The South Pole Wall appeared as a massive, curving line of galaxies in the southern sky. The Discovery team also measured peculiar velocities, galaxies' motions not caused by cosmic expansion, but by gravity. These motions revealed the wall's immense mass and extent. By analyzing these cosmic flows, astronomers confirmed the South Pole Wall's presence. It's a triumph of mapping and inference, not just observation. And it shows how much more there is to uncover. The South Pole Wall raises new questions about the universe. Are such structures rare flukes, or do they reveal deeper cosmic principles? Its gravity affects our local group's motion, adding complexity to the cosmic tug-of-war. Is the wall even bigger than we think? Future surveys may reveal its full extent. Most profoundly, does its existence challenge our understanding of dark matter, gravity, or the very fabric of the cosmos? The South Pole Wall is an anomaly, vast, dense, and improbable. The cosmological principle says the universe should look the same everywhere, but this wall is a giant exception. The universe's age sets a speed limit for how big structures can grow. According to our models, there hasn't been enough time since the Big Bang for such a structure to form. Maybe the early universe was lumpier, giving gravity a head start. Or perhaps our models of dark energy or gravity need revision. The South Pole Wall is a powerful constraint. Any theory must explain its existence. It stands as a challenge, urging us to look deeper and question our assumptions. Why do we care about a giant wall of galaxies? Because exploring these mysteries is part of who we are. Each discovery maps our origins and reshapes our understanding of the cosmos. When observations clash with theory, science advances. The South Pole Wall is a lesson in humility, reminding us how much we have yet to learn. Investigating it connects us to the universe, replacing loneliness with a sense of belonging. The pursuit of knowledge is one of humanity's noblest quests. And as long as mysteries like the South Pole Wall exist, the universe will keep calling us to explore.